Hi, welcome back to the PM session of today's workshop. So in this afternoon, we'll be going through with you guys how to develop plugins to use alongside AI Verify Toolkit. So the agenda for today is as shown on the screen. We will have some introduction on what the PM workshop is about. We will share briefly about the AI Verify Toolkit architecture, followed by what is actually AI Verify plugins, what are plugins made out of. After which we will be going into a series of hands-on tutorial where you will be coding the different parts of a plugin. So it will be broken up into 4 parts, and we will have breaks in between so that you don't get too tired. Yeah. So going into agenda of today's workshop, I have briefly went through just now, but just to give a deeper dive into what the hands-on workshop will be about. Firstly, we will create a plugin skeleton. Then the first tutorial we will have one of our engineers go through with you how to create a mock testing algorithm that is part of the plugin. Then tutorial 2 will be going through with you guys how to create an input block to capture user input. And tutorial 3 will be creating widgets to display the test results and the user input that you have captured. And lastly, we will also share about this AI Verify playground that we have, and also how to generate the entire plugin and how to install plugins. And we will end off today's session with a Q&A as well. So as I have shared in this morning session, AI Verify is built in an extensible format such that you can build all these plugins on top of the core toolkit. So these plugins cover 4 key areas. So firstly would be the report template plugins, which I have demoed this morning. And these report template plugins will allow you to build sectoral reports that are designed for specific use cases that you can share with other AI Verify users. The second type of plugins that we support will be display components. So these are the widgets that you have seen, the drag and drop components on the canvas page. So these are also a type of plugin component. And we will be going through later on how to build these display components. On the third, we also have testing algorithms. So these are the real sciences behind all these technical tests. So it will be the algorithms to help you run tests for fairness, explainability, and robustness. So for the sake of today's workshop, we will be using a mock algorithm instead of an actual one. So there will be some sample codes that you can copy and paste later, just to help you understand how the architecture of a plugin works. And lastly, we will also go through with you how to build workflow components as plugins. So workflow components are things like your fairness decision tree, your process checklist. So basically components for you to capture user input. So all 4 of these components can be packed together inside a zip file, as one singular plugin if they serve a singular function. And if you look at the yellow box around, we do have AI Verify developer tools that will help you generate a skeleton code that can help you facilitate the development of these plugins. And if you had the chance to install our VM, we have already installed the sample codes and the AI Verify developer tools into the VM. So we will be using the developer tools to go through the tutorial later. So the objectives of today's workshop is to equip you guys with the knowledge to utilize AI Verify developer tools to build plugins for AI Verify. So by the end of the workshop, you should feel confident and empowered to build meaningful extensions through testing algorithms, user input blocks, report widgets, and also report templates for AI Verify. So without further ado, I would like to pass the time to Peyot. So Peyot is one of our front-end engineers, and she'll be sharing a bit more about the AI Verify architecture.
Hi, I'll be sharing with you what's the overall architecture of the AI Verify toolkit is like. Currently, for the AI Verify software, the main architecture actually consists of 3 major components. One is the backend engine, which is where we run the AI testing with the output and things like that. And then we have front end, the front end components, which consists of 2 parts. One is the portal, where we display the UI and where you see when Kimi walked through this morning the portal, that is the front end, that is the UI part. We also have the front end also consists of a middle layer, which we call the API gateway, which where the actual business logic is being handled. And the all three components of the AI Verify the toolkit, right, actually communicates using the Redis database. So this is I would say a more detailed version of the architecture. What you showed just now is the three major components, right? The portal, API gateway, test engine. So I mentioned portal is the one that handles the UI user flows. And this is also the part where we also have a plugin manager in the portal side that allow user to, when you have finished building your plugins into the and you compress the zip file, you can upload the plugin from the plugin manager in the portal. So the portal will be able to read in the zip file, extract it, and also save the plugins under the plugin folder. The API gateway is the one that actually handles, I say it's a middleware that actually handles all the business logic. We also uses MongoDB here to save all the portal informations. Portal informations like the projects, even the templates are actually all being stored currently in the MongoDB. MongoDB is only used by the API gateway lah. So things like your test results when you finish executing the test. As well as, for example, when we are running a project, if there are user inputs like the process checklist, the information are all saved inside MongoDB itself. And API gateway, we have two types of APIs that we use. The main thing is we use GraphQL, that is basically an API language, I would say, that allows user to query the API gateway for information that the list of the projects and the list of the reports. Then we have your more commonly used the RESTful API, but these are mainly used to upload files. Like when we upload the data and models, this will be posted to our REST API, and it's all saved under the portal directory. The reports generated are also saved under the API gateway directory. Finally is the test engine. So the test engine serves, the main function of test engine is to execute the AI test, and the result actually will be posted back to the API gateway, which then take the result and save to the MongoDB. So this is the part where you can see that all three main components communicate with each other using Redis. For Redis, we make use of it in multiple ways. So one is using the Redis streams. So what happened is Redis stream, we use it to queue some of our jobs for the tasks that from the front end when we try to communicate to the backends. Like for example, every time you generate reports, and we will break out the test to be run as what we call the job queues. So that will be posted to the Redis message queue. And the backend engine will pick up the jobs and they'll run it. Then finally, the results from when they finish the jobs has finished executing will be posted back to the front end, also using Redis, the hashes. So in this way, our backend engine, we are able to run concurrently for different workers. We have backend engine has worker process that actually can pick up and execute tasks in parallel. At the same time, we also use the pub subs in order for the backends to notify the front end on certain things, like for example error messages, some alerts. So if there are any system error or whatever, the backend will post all the error messages through the Redis pub subs. Front end will pick it out and will display in the portal. So that's how we utilize Redis as a communication channel between all these three things. And at the same time, the Redis key value database, right, the HHAC set is also where we save the plugin registry. So all the plugin informations, the plugin metadata, the where we store the files are all being stored in Redis as well. And the registry is also, that all three components, front end and back end, can query the same registry. This one Kimi already covers a bit just now, so I'll just reiterate. So for our plugins, AI Verify is designed to be extendable using a plugin architecture. So besides the base component that I showed just now, we also allow developers like yourself to extend the functionalities of the toolkit through plugins. So AI Verified, the main platform itself already come with a basic set of plugins that you all can use out of the box. But if you all wants to build your own plugin, this is where one of the ways where you can create, for example, your own algorithms or your own widgets for your reports and things like that. So for plugins, there are 4 different types. One is the algorithm itself. So this is actually the Python libraries that actually runs the algorithms, and then returns the result. Then we have the widgets. Widgets are, if you remember during the workflow this morning, we have a canvas page where we can drag and drop the widgets from the sidebar to the report canvas. So all those widgets are being built here, including the stock widgets. Input blocks are not for the reports. Input block actually separates, I'll say, front-end components that allows the projects to capture additional user informations that are not being captured, that are not for algorithm, like the process checklist. The fairness tree that we also showed this morning is also also built using input blocks. So these are also additional data that's outside of your AI algorithm testing. And then we have the report templates. So the idea is for our reports, we wanted it to be the same report templates like our Word documents. You want to have the same report templates that can be reusable across different reports. That's why the report template, this is where the report template comes in now. All right, so for plugin, the file structure actually looks like this. So each plugin will consist of one or more of those 4 major components. So it need not be all 4, can be either one or all 3 these or components. The file structure for each of the widgets, inputs, templates. You can have multiple widgets, but they are all more or less flat directory here like that. So for each widget, we have the widget MDX file itself. Later, my colleague Amin, when he's talking about the widgets, he'll explain a bit more about what MDX files are. But this basically, MDX are what we call Markdown plus JSX file that allow us to build the widgets that forms the code for the widgets. And each component, right, they will have a .meta.json file. This one is actually describes the meta information about the component itself, like for example, the name of the component, the CID, the GID. So all these here these are the 4. For algorithms, because they tend to be much more complex, so algorithm is a 2-layer. So each algorithm will have a subdirectory under the main algorithm folders. Then when all these files, when all these files are ready and it's being tested working, right, we just compress it into a zip file and it's ready to be uploaded into the AI Verify toolkit through the plugin manager. Okay, I will show you what the plugin manager look like. Okay, so if from the portal side, right, if you click on plugin, so the plugin manager actually looks like this. This plugin manager will list what are the list of plugins you can see from the sidebar here. So these are the list of plugins. And these are the stock plugins that currently comes with the AI Verify when you install. So each plugin, it can consist of different types. And you can view what are the components in each plugins. Like here, for example, what's the widget for this accumulated local effect, then the algorithms, and for each algorithm, we'll go into more detail later on, but each algorithm also has the Python libraries that may be dependencies. So our plugin manager will check that these dependencies have been installed in your development environment. And the widget will list the widgets. So the widgets here are the ones that in the reports canvas, you can drag and drop from the sidebar. So that's it. Then to install a plugin, it's just to click in the plugin manager here. From here, you can upload your plugin if it's successfully validated. When you upload, we'll do a run of validation to make sure the files are all valid. So once it's all validated, it will be installed. That's how we install into the plugin itself. Then this one is this is the AI Verify developer tools. So the tutorials later on will use that. We will show you how to use the tool to create the plugins. And these are helper tools to make it easier for you to create plugins. So this one is actually you can find the tools on GitHub already, and this is the link for it. If you look at the GitHub itself, there's a about here, right? About page here. So over here is the developer documentations, and you can see the instructions here on how to install the tools. If you want to use it, want to install it on your machine. So the VN already comes with a copy of the developer tools as well as the AI Verify main project itself. All right, that's all. So I'll hand over to my colleague Kelvin here, who will start the tutorial sessions.
Yeah. So I'm Kelvin. I'm a backend developer. So I'll be going through the creation of the plugin for the backend. Okay, so this is what we'll be walking through for the rest of today. So we'll be going through the steps to create the components for the plugin. So the first step will be to create a plugin skeleton. Then subsequently, for my part, I will be covering how to create a mock plugin, which is the backend component of the plugin. Then my colleague Amin, he will be going through the input block and the widget, which are the front-end components of the plugin. So at the end of this session, I think everybody should be able to create your own plugin and understand how the components work. I think just now we also shared that there's a developer documentation. So if you want to know more about this after this session, you want to create your own plugin, you can refer to the documentation. Okay, so has everybody started their VMs? Do you all have AI Verify running? Okay, so in the VM itself, right, we already have a VS Code installed. So to start the project in VS Code, you just have to open a terminal and type this. Yeah, so you all can just open the project in VS Code. So for me, I'll just open a terminal, then yeah, so once you type that in the terminal, you'll see that the VS Code has opened with the project there. And actually, to make things easier, you can just open a terminal in VS Code as well. So just open a terminal here. Okay, so there will be a bunch of codes that we will need to enter for this tutorial. So in the project folder itself, you should find that there's this folder called tutorials. So inside the tutorials, there are some snippet codes where you can copy and paste instead of typing them in, yourselves. Okay, so we will start by creating the AI Verify plugin project skeleton. So I think this is okay, let me just open the tutorials. Okay, so this should be in this, the commands that you need will be in this create plugin.sh. So you can just open this with a text editor. Yeah, so you can just copy the commands step by step. So the first step is to just cd into the project. Oh, actually I'm already there. Okay, so you just have to type the command, the next command, which is to create the plugin. So over here you can see, okay, so this command actually is a command for you to create your plugin, and you need to specify what is the name of the plugin and the description. So the GP here actually means generate plugin. So to copy this command, you can just go to the file we have over here. Yeah, you can copy this line and just paste it into the terminal. Okay, so once you execute this command, you can see that you should have this my plugin folder created. Also, once you create the skeleton, you can see there are some files created inside. So there's going to be a git ignore, some license, and the plugin meta.json. So the meta.json is just a file for you. Just now when we create, right, specify that the name of the plugin is my plugin, so it will be reflected here. Then the description will be here as well. Yep, so you can do a ls to see what's inside the plugin, but this time is not necessary. Okay, so once we have created the plugin skeleton, we can proceed to create the mock algorithm. Okay, so the mock algorithm will be in Python. So this is the backend. This is the backend component. So it will be in Python. So the first thing we have to do is to activate the virtual environment. So a virtual environment is like it's an environment where we have created with all the necessary libraries installed. So you don't have to install them. So to activate the virtual environment, you can copy the command that we have provided in the file. So you can look under tutorial 1, which is the mock algorithm tutorial. Yep, so you can just copy this line and paste it in your terminal in the Visual Studio Code. So once you have activated the environment, you will see that there's this v and v in front. Okay, then after that, the next thing we have to do is we have to change the directory into the folder that we have just created. So again, you can copy the commands that we have provided. Okay, then now you run the command, the AI verify command to create the plugin. So you can again just copy this. So what this command does is that it will GA stands for generate algorithm. So you will be creating an algorithm, and the name of your algorithm will be my algorithm, and the description is what is here. And you can just enter. So once this command runs, you will see that there will be an algorithms folder created. And inside there will be a bunch of files that we have pre-generated. But for today's tutorial, I think we'll be going through some of the main files, so you don't have to care about that. I know there's quite a bit of files, but then we'll be focusing on like the input schema and the algorithm file itself. Okay, so the first thing we have to do is to create the is to update the input schema file. So the input schema file is a file that will be in all your algorithm folder. And okay, so what this file does is that it's a file that you will specify what you will be inputting into your algorithm. So it's like what you're expecting as the input. So in this case, for this tutorial, the thing that we'll be expecting will be this field called feature name. So you can see like there's this like required field there, then there's a feature name inside. And then what this feature name is will be defined in the properties field. So in the properties, you can see that we are talking about what feature name is. So feature name is, the title is feature name, and this is the description. And the most important thing here is actually the type. So in this case, feature name, we are saying that it's a string. So so this file, another purpose of this file is to validate what the user inputs. So for example, in this case, my algorithm is expecting a string called feature name, and it's supposed to be a string. If the user enters a feature name, but then they pass in as a number, it will fail the validation. So this is what this file is about. So I think in our codes, we will have to copy the part that's in yellow into your input schema JSON. So in input schema JSON is currently there's nothing here. So you just have to copy the codes from the file. You can just copy everything here, then you just replace everything that's in the input schema JSON. Okay, so once you have defined the input, so that will be the input for the algorithm. Okay, so the second thing we have to do is to update there's this main file in our algorithm. So this main file, I have to specify that it is not something that will be packaged as part of the plugin when we deploy. So it's just a file for us to test our algorithm on the back end without the front end. So in this file, we will be defining what we want to test with our algorithm. So for example, in this case, you can see that for my algorithm, I'll be testing with this data called sample BC credit data. This will be the data set that will be run. And for the model that I'll be using to test, it will be something that I have defined as well. And all these are provided in the AI Verify repository. And for the ground truth path, it will be a set of data that contains the ground truth for your testing. And in this case, for example, our ground truth column, we'll be taking this column called default from the ground truth dataset. And for this model type, it will be also support classification and regression for the model type. And for this tutorial, the model type will be classification. And then there's another field which is run pipeline. So run pipeline is whether or not the algorithm we are running is it a pipeline. So in this, the one that we will be running for this tutorial will not be a pipeline, so it will be false. Yeah. And yeah. Okay, so the things that we have to modify in this file will be the ones in yellow. So the core module path and the plugin argument values. Okay, so the core module path is actually a path that we have defined to point to this directory called test engine core module. So test engine core module is a directory that contains all the AI Verify support that we have. So if you do a LS, if you want, you can do a LS to see what's inside. So there are things like the data deserializers, like Panda deserializers, and the models we support like sklearn or SGBoost. So all these are things that we support out of the box. Yeah. So this is something that you have to modify. And another thing we have to modify is this thing called plugin argument values. So for this, these plugin argument values are things that our algorithm is expecting. So in this case, we are saying that our algorithm is expecting a feature name, and the feature name that we'll be taking in is called gender. Okay, maybe later I'll explain a bit on why is gender. But for now, let's just copy this and modify our main file. So over here, you can open your main file. You can see there are some to-dos which we'll be replacing. Okay, so you can open the code.py. So code.py, there will be the codes that you will need. So the first thing we need to do is we have to copy this core module path, and we will just paste it in our main.py. And then we will do the same for the plugin arguments as well. Oh, sorry. Sorry, it's this one. It's the one at the bottom. Okay. Yeah. So after modifying, you should have your own core modules path and your plugin arguments. Yeah. So this file will just be us defining what we want to use with our algorithm. Okay, so that's for the main file. And okay, so after deciding what we want to use with our algorithm, we will need to modify the algorithm itself. So in the algorithm, which is in the main Python file, my algorithm.py, there's a bunch of functions that are predefined. So all these things, you don't really have to modify them. So the place we will have to modify, maybe you can do a search for the word generate. Is this method called generate? So generate is the function where we will put all our logic for this algorithm. It's the entry point, basically. So for example, like the processing of the data set that you will be inputting into the algorithm and like calling like your own model to do prediction, all the logic will reside in this method. But then for today's tutorial, we won't be doing something like that. We won't be doing something so complex. So instead, we will just be outputting something more static as the output of our algorithm. Okay, so once you have located the generate function, we will have to modify a few things. So the first thing we have to modify is this, the first line in yellow. So what we are doing here is we are saying that in the input arguments that we have specified in the previous step, we will be getting this value. We'll be looking for this key called feature name, and we'll be getting the value and assigning it to my user-defined feature name. So this is the first step. So we can copy the code over first. Yeah, so there's this to do. You can just paste it below. Okay, then the second step will be to assign something to the result of this algorithm. So this every algorithm there should be an output, right? So you can see this self._results is where we'll be assigning the value. So this is something that shouldn't be changed as well, just FYI, because when we are looking for the results from the algorithm, this is the particular variable we'll be looking for, which is self._results. So when you're coding on your own, after you have the output somewhere, you will need to assign it to self._results. So in this case, we can copy this line, which is to assign something to self._results. Okay, so what this line does is that instead of doing a prediction on using our model, what we are doing is we are simply taking a column in our input data set as the output. So in the previous step, you can see that we are looking for this feature name called gender. So our feature name is the field name gender. So I'll be just taking the gender column from our test data set. I'll be taking the value, then I'll be assigning it to this variable called my expected results. And this will be the output of our algorithm. Yeah, so when you're coding on your own, I think it won't be so simple. Of course, you'll be calling your own prediction, you'll be processing the data set. But then for this tutorial, we will just be assigning this as the output. Okay, so once we have modified the algorithm, we will need to update the output schema. So if you recall just now, there's an input schema file. So the input schema file is to define what your algorithm is expecting. And the output schema file is just to say like what you're expecting for the output of this algorithm. So in this case, you can see that for this algorithm, we'll be expecting this field called my expected results. And my expected results will be an array of minimally 10 items, and all the items inside should be a number. So again, we can just copy the codes in tutorial 1. So this one will be in output schema JSON. You can just copy the whole thing and paste it. Also, one thing to note is that this input schema JSON, we are using this format called JSON schema. So JSON schema, there are certain fields like properties and required, and all these are like open source standard. You all can look it up if you want. So this is what we'll be following. Okay, so so far we have defined what we are expecting for our algorithm, and we have defined what we want to test with our algorithm, the input data set, the type of model it is, and the input argument. And then we have modified our algorithm to read the data set and set it as the output. And then we have defined what we will be expecting for the algorithm. So with all this, we can actually run the algorithm to test if it's working. Okay, so you can copy the command and run. Okay, so you can cd into this folder, my plugin. Okay, I'm already here. Okay. So you need to run this command AI verify plugin test A. So test A means that you will be testing all the algorithms in this folder. Oops. Okay, wait. Oh, yes. Thanks. Yeah, so you should see this like one test run and one test pass. So this is actually the column from the gender you can see in our test input. Then it is what we are expecting. So it's an array with at least 10 numbers inside. Yeah, this is only to check whether the data type is correct. We are not checking the input. We are just checking to see that the data type returned is what we are expecting. Yeah, so that's the sample algorithm that you have created. That's all for the algorithm. So the next part will be, Ami will be covering how we will be creating the input block and widgets for the front end.
Everyone, before we continue the next part of the workshop, I've heard some questions and discussions around. So I just want to clarify one thing, which is around the why plugin and why we need to execute this to set up the plugin architecture and things like that. So plugins actually have three components that I think Peggy shared earlier. So the three components are display, which is the display widget, which I'm going to walk through shortly, algorithm, which is the part of the code that actually tests the model. So this has nothing to do with the model, this is the code that actually runs the test, like shared, like committed local effects and all the different fairness tests. And then the last part is input blocks, which Ami also go through, which captures inputs from the users. The reason why we have this in this structure is because we want at the end of the day for you to be able to zip this up and then distribute it, and then people just install it like Video showed through the portal. Now we understand that sort of running the code and all this, a lot of it is about just building the structure necessary to assemble the plugin. It is a helper tool to basically make sure all the JSON, all the sort of metadata is there, and that is why we have this dev tool to build the plugins. And just want to see if there are any other questions around the nature of plugin structure or anything that we can clarify before Amin gets into how to build it. Okay, if not, thank you. Over to you, Amin.
My name is Amin. I'm the front-end developer and I work on AI Verify. I will be doing the remaining tutorials, and all of them are related to display components. There'll be no more Python code basically. Display components, firstly I'll be doing the input block. We'll be doing input blocks, and then the next tutorial will be the widget. So the widget will display the output of the algorithm which you just built, and also the widget will display a few data which is captured in the input block. And then the last tutorial will be about a playground which will help visualize the input blocks and the widget that you build. And how we're going to do this, we're basically going to we're going to use the same command line tool, AI Verify plugin. And for those who have their VM setup, and you've been following along, I'll be doing hands-on, and then you can also follow along. Otherwise, you can just tune in. Yeah. So I tidied up my view here. We're going to remain in. So earlier you created a My Plugins folder. Let me just show the slide first. Okay, you completed the mock algorithm. We're going to do this one. We're going to build input block. All right. So you already created My Plugin just now. So we remain in this folder, and then just verify that your AI Verify plugin works. Yeah. And then in my VS Code, if you are opening the project folder, your My Plugin folder is there, and the tutorials folder is there. So you can jump between these two folders and in this panel, right? So My Plugin was just what you guys created for those who followed. The algorithm is there. And then if you need to refer to the, tutorials, the codes, you can expand the tutorial folder below. Okay, so this is how I'm gonna do it. So there's no more Python code. AI Verify portal, you've already seen it runs in the browser, right? So if it's in the browser, the input blocks and the widgets are all display elements in the browser. So that basically means HTML, right? HTML, JavaScript, CSS, but we won't really do so much of those. We'll just touch very basic HTML things. But I do want to show you a bit of a syntax, HTML syntax. You guys probably know, but just to show you the syntax of it, right? So because later you will see similar syntax, but then it's not really HTML. Right? So in HTML, I think you surely seen this before, right? A block of element is a div, and then you can have headings, for example, right? Heading, and then you can have a p tag. Right? So this is a paragraph, right? So this is HTML, right? And then I think the other common one will be input. Input type equals to text. Okay, so angle brackets, and then the name of the element, H1, quite self-explanatory, headings, input, and there's a ton of others, right? If you've done HTML, you probably know. If not, if you look up HTML, there's so many other elements. And the browser engine, basically, when you load a HTML document, it passes this string here, this string of HTML codes, and then each of these get turned into objects, and then the engine will render the corresponding visual elements on screen. And then there's another thing. There's a script tag, and you can write JavaScript in here. So when the browser passes through your HTML document and you reach a script tag, and then let's say you write a constant variable, constant name equals to my name, and then you start writing functions. Right? So when the browser reaches this script tag, the browser spins up a JavaScript runtime and executes JavaScript code. Okay? So that's the second thing. And then the other thing, there are events. The last thing I want to talk about is, I want to mention it quickly, is there are events in HTML. So, for example, you can put, normally you don't put it here, but there's an on-click attribute, and then you can put in the JavaScript function to handle on-clicks. So, other than on-clicks, there's so many other things, on mouse over, or on change, right? For input, there's on change and things like that. So with these events and HTML and JavaScript, right, that's how UI is being done. You hook onto the events, and then you write JavaScript functions which say, okay, update the heading color to red and things like that. So that's how UI basically done. This is a fundamental concept. So, but look at this syntax here. This is what we're going to kind of write. I'm going to delete this one. Okay, so let's create the input block. So if you remember, the input block is somewhere along the flow just now. After you drag and drop a widget, and then you go to the next screen, there can be some blocks in there where you get some input fields, and then you can type in whatever the forms ask you for, right? In this case, we are just going to build a simple input block with two fields, right? So if you are still on your command line, all right, under tutorials, tutorial 2, you can go to generate.sh. You can copy AI verify command. In the same My Plugins folder, you run this command. Right? Oops, gibberish. So AI verify plugin, GIB, generate input block. You give a name here. I think this will be taken as the folder name or no, a file name, and then some metadata, name flag and description. So enter, and then if you do an ls, you should see a new folder being created called inputs. Right? And inputs contain three files called myinputblock.mdx, metadata.json, and summary.mdx. So you saw that they take up the name of what you input in the command earlier. Open up the input block mdx. You can just remove everything. And then we're going to start composing the visual elements here. If you go to tutorials, you go look at code MDX under tutorial 2. So this is what we want to copy and paste. Tutorial 2, code MDX. Go to myinputblock.mdx under your my plugins, inputs, and then paste them here. Yeah. So we are creating two input fields, one for first name and another one for last name. We also put labels to those input fields, and we wrap them in a div. But there's something a bit different here to HTML. Firstly, the file name is not HTML, right? The file name is .mdx. And then there are these curly braces in here. In normal HTML, you use double quotes. And then the value also, you see some curly braces here. So there's a mix of actually JavaScript and HTML-like syntax here. Okay? So this is actually a technology from React. It's called JSX. Right? So React lets you write HTML kind of elements, compose HTML kind of elements using this syntax, which also looks like HTML. You literally have all of this label input, div, h1, a anchor tag, whatever you get in HTML tags, you get in one-to-one in JSX. So this is JSX, but then JSX allows you to like mix in some JavaScript in there, like value, props, data, fname here. Like you probably wonder what is this props, and then on change. I spoke about on change event. So it basically means if you change the value in the input field, this function gets executed. So JSX is you write it normally in JavaScript files in React, and then there's a transpilation step, there's a compilation step, or you can call it transpilation, which transpiles this into HTML. So this is actually a higher level language above HTML. Right? So you code in this, and this gets transpiled into HTML. And then you get these extra things. Okay, but during the transpilation, what this actually is this. When you compile this, it actually becomes somewhere during the compilation, it actually becomes a function. Everything gets wrapped in a function. And then there is React already provided this. I'll just call it div function. Not accurate, but I'm just trying to give you an idea here. A div function is being called, and then the div function actually corresponds to this div, the parent div. Right? Now this parent div has got child elements inside. So what happens is actually inside div function, no, not here. in the body of div function, label elements gets called. Label function gets called. Right? And then with attributes like fname, well, all this actually gets passed as arguments. And then beside label is input. So we are still inside beside label function, and input element gets called, input function. So this whole thing is actually a big function which comprises of small functions, and they kind of get executed, and then the whole div, the whole HTML gets generated. Yeah. So if you just to summarize, if you don't really get it, this is a higher level language, JSX. You code in this, it gets transferred to kind of functions. All of these elements becomes functions, and then if there are child elements, they get called inside the function. And then the highest level, there's this argument called props, which gets passed to the parent function. Right? So props gets passed down to all your inner functions. So this actually, that props is actually this. So props is like a dictionary during the runtime, and then inside props there's when user inputs the first name and the last name, it gets appended to data in the props dictionary. And then onChange is also onChange data is also a function which is attached to props, and then all of them gets passed into the parent function, and then all the inner functions gets the props. So that's what props is actually, right? So we've done the input block MDX, and then next is summary. Okay, summary MDX. So during the report generation flow, after you drag your widget and then you input your input blocks, during the input of inputs and input blocks, there's a kind of a progress on the left. So trying to show you that you've completed how many percent of the form. Like your form could be huge, right? There could be 10 fields. So we have a summary mechanism to show how much you completed, and that's actually here. So in this case, let's just remove everything. Go to tutorials, tutorial 2, code MDX. Sorry, tutorial was not here. Alright, never mind. So remove whatever that's on top. Undelete if you deleted. Change the total keys to 2. So this, what you want to write here, you want to write a JavaScript function which returns a percentage. So whatever your input block is being designed like, in this case there are 2 fields. So the first name and last name. So we just want to calculate the percentage of completion. So you write a function to reflect the percentage of completion. That's all. And let me see whether it returns. I think it should be in the tutorial folder. It is not? Okay. And metadata JSON, there's nothing to change there. All right? And that's it for input block. So input block is done. We'll move on to the widget itself, tutorial 3. Okay, remain in my plugin folder. Go to tutorial 3 in the tutorials, generate.sh, and then copy the command. Okay, make sure you remain in my plugin folder. We're going to use the same command line tool. This time is GW, generate widget. Give it a name. Now there are quite a number of parameters here. Name is self-explanatory, we give it a name, metadata stuff, description. But what's important here is the DEP flag. So DEP flag, we are saying that this widget that we are going to compose is going to be dependent on the algo that you just created. So the syntax is algorithm. Algorithm is basically fixed, separated by a comma, and my algorithm is the ID of the algo that you just created. So whatever algo that you created goes there. All right. So we are telling the tool that the command line tool that we are going to build this widget, and this widget is going to use something from my algorithm. And we have another dependency flag. Syntax is input block, comma, and my input block, the ID of the input block that we just created just now. Right? So this widget is going to display the output from that algorithm, and we also want to display the value of the inputs that you will put in during the flow later in the input block. And then this minimum width 12 is a canvas stuff. It's a drag and drop on the canvas thing. The canvas has got a grid system, so we're saying that minimum, this must be a minimum of 12 width. And because the algorithm just now churns out like a lot of data, right? So you can imagine when you put the widget onto the canvas page, it's definitely going to spill over multiple pages. So if you know that, and you kind of need to indicate here with dynamic height that you're generating a plugin that might spill over multiple pages, so that when it prints, it will print nicely. Because on canvas, it doesn't show you multiple pages. It will just be truncated. So run this command, and then you should see a new folder appearing. Widgets and some files in there. Right. Similar pattern to inputs, follows some file name, but you also see some sample JSON. We'll talk about sample JSON later. Input block also has got a sample JSON. The first thing to do is it's always the MDX files. The MDX files is where you compose the visual elements. So my widget MDX, you can remove everything and copy from tutorial 3 code MDX. And then paste it into the newly created mywidget.mdx. Okay. Now what the widget is going to do is just going to display the whole zeros and ones that algorithm churns out into a div, nothing fancy. And then below is going to also take the outputs of this one is the input block. First, it's going to take the data from what user inputs in the input block just now, the first name and last name, and display it on top. And then below is going to get the data from whatever the algo run returns, and just display it in a code like pre-RE is like a tag to kind of display like maybe code setting. Yeah. But what's important is this first two. So you got to do an export variable name, and the first one, algo CID. Basically, we want the ID of the algorithm to be here, and then the second variable, the value, we want my input block's ID. Right. So if you go back to inputs and then you look at metadata.json, the CID is there. So this is what we want. Right. I think even in algo, same. Algo has got metadata, has got CID. So this is the ID that we are referring to. So in my widget, we do this. We put this in variable, and then remember this whole thing compiles to a function, and then props gets passed into the function, and then in props there's this. The platform will provide you this function. So we just follow this pattern. In props, there's this function called get input block data, and then it takes the string of this variable, which is the ID of my input block. So you see there's a mix of JavaScript and HTML-like syntax, JSX, right? So ignore this. This can just be div actually, right? But JSX, they provide you, if you don't want to wrap your elements in anything, any elements, you can just use empty text. This is a JSX specific thing, because it is just a rule that in JSX you must have a parent element around your child elements. If you don't put any parent element, you won't compile. So that's why. So this can be a div, but in JSX it can be empty. So we are saying here, this is like an if-else, a simple if-else statement or a shorthand of if-else. So basically what this means is, run this function. If it returns something, if it is not undefined, whatever is not undefined, we execute this. Otherwise, execute this. Right? So if there's data from here, we'll be printing this in the widget. If not, we print this. Shorthand, if-else shorthand, right? Let me just repeat. The return of this function call, if it's not undefined, execute this, and then it's separated by a colon. If it's undefined, print this, no widget data. Same below. If there's no algo output, if it's the other way around. If it's defined, print this. If it's not defined, print this in the widget. Okay? It's the other way around. Alright. So that's done. Now we talk about sample. Okay? So go to your tutorial folder, my algorithm sample, copy what's in here, go to your widget which you just created, and under widgets folder there is the algorithm sample.json. You put it there. So this should conform to the output of your algorithm. So your algorithm, remember, you define my expected results, and then it's an array of number. In this case, JSON schema number means is your integer or floating point numbers. Right? So why we have this sample data? Because when you drag your widget onto the canvas, it's empty, right? You won't populate. It won't be populated until you print the report. But with this, you can kind of visualize it on the canvas. It will populate sample data for you. Right? And then input block also has the same thing. So input block was the first name and last name field. You go to tutorials, tutorial 3, input block sample, your F name and L name dictionary is there. Copy it, and then you can paste it in your my input block sample.json. So my algorithm sample, my input block sample, your JSX in my widget, and you have your metadata. And if you look at your metadata, you will see dependencies properties here, because you ran in the command line. You define that you have two dependencies. My algorithm is my algorithm. This widget is also dependent on my input block and the command line. This gets generated. This gets generated, right? And then we put minimum width 12 just now. So if you want to change, there are a few other flags, and you can change at the command line. They will be updated here. And that's pretty much it for widget. I shall continue with tutorial number 4. Okay, tutorial number 4, we want to show you the playground, right? So the command line tool comes with a playground to help you visualize your widget and input blocks. So if you go to your VS Code tutorial 4, it is a plugin. Oh, the command is not there. Okay, never mind. So the command is this. Oops. AI Verify plugin space playground. Stay in the same folder. You're going to stay in the same my plugin folder. Let me just clear this. So while you're still in this folder, AI do the same command line, verify plugin space playground. You hit enter, you will see something spinning up, and it's listening on 5,000 on a local machine. Right? So you can go to your Firefox. And then go to that 5,000. It's going to take a while. You can check your command line. Some compilation is going to happen. This first time it spins up, it takes a while. And try clicking on the buttons here. If it doesn't appear, just give it some time. It does take a while. Yeah. So once that compilation thing finish, you should be able to see this screen. So we just created my input block. Okay, my input block, when you just click it, I think it's going to do some compilation again. Compile, okay. Right. So this tool helps you visualize what you just created. The input blocks first name and last name field. Right. But what's even helpful is with this. Now, if you go back to, I'm just going to close this once. Go to inputs and go to my input block, and then let's say on the the first name field, I'm going to add some CSS there. CSS syntax. You can put a style attribute there, style, double quotes, and then I'm going to change the height to 60 pixels, separated by semicolon. I'm going to say border 1 pixels solid red, and then I save it. Oh, I think my syntax is wrong. Never mind, let's just don't do this. I think I have to use I forgot, maybe it's a single quotes needed, but let's just do 60 pixels and just refresh this. Oh, sorry, this is JSX, so cannot use double quotes. I go and use HTML syntax here. So, curly braces, right? Border 1px solid red, and I'm going to change the height to 60. Let me just reload this thing. Yeah. Right. So you can tweak your elements, and then you see it reflected here. And this simulates the canvas in Portal. When you drag and drop the widget, this is what it's going to look like. And then we created sample JSON just now, so they get displayed here, right? John Doe was the sample JSON, the data that we put in sample JSON, and then the mock expected results. So this is how it's going to look like when you drag the widget onto the canvas. If you click on My Algo, then you will have some information there as well. Yeah, so in my algorithm earlier, I think you define a required field, feature name as required. This is how it's going to look like. So somewhere along the flow, before running the test, user will be prompted to input feature name, and then this just shows you what the field looks like and some information around it. So you can play around with this, and that's the playground. The last thing we're going to do, we can now package this whole thing as a zip file, and then we can share the plugin or install it on Portal. Alright, so let's do that. I'm going to kill this playground, clear it. In the same My Plugin folder, you do AI verify plugin, and the command is zip. Yeah. Oh, I got an error because my algorithm is invalid. Oh, you need a virtual environment. Okay. So if you face the same error, it's basically you need a virtual environment now. This is the Python virtual environment. Okay, make sure you have the VMB prefix there, and then if you run zip, when it's done, you do an ls, you should see this folder, and it should contain my plugin 100.zip. So you've pretty much packaged your plugin, and then let me just show you where how we can install it. Host, you can run the portal, go to plugins manager, install plugin. This is a folder, home, project, my plugin, this folder, zip file, install. Yeah. So once it's installed, it will be immediately highlighted here, and you can see your widget is there, right? And it's dependent on my algorithm, is dependent on my input block. Your algorithm is there, and your input block is there, right? And it should also appear in, let me just create a new project. It should appear on the sidebar now beside your report canvas. I'm going to do a blank canvas, next, and there at the bottom you see my plugin. If you land on this screen, you expand my plugin, my widget is here, and you can drag it. Yeah. So notice the dynamic height here. So we are telling the platform that this widget is going to, it can spill over multiple pages. So however you resize it, it will always be flush to the bottom, so that you cannot put anything at the bottom. Right? Even if you resize from the bottom up, it will just make sure it's flush all the way to the bottom. So that's a dynamic height. And that's pretty much. Yeah, so we've come to the end of all the tutorials actually.